Hello and welcome to Algebra 2 Lesson 15. In this video, we're going to learn about linear equations in two variables. So this is not a new topic for us in Algebra 2. We learned about linear equations in two variables in Algebra 1. But for some of you, you never took an Algebra 1 course, and for others, you kind of stumbled through your Algebra 1 course. So it's important to get a good full review here. So the first thing I'm going to talk about is up to this point, we've only kind of worked with a linear equation in one variable. We also talked about linear inequalities in one variable and some variations on that. We looked at some absolute value stuff and some compound stuff, so on and so forth. But the main idea here is that a linear equation in one variable has generally one and only one solution. So for this type of problem, let's say I have negative 2x minus 5 equals 15. I add 5 to each side of the equation. I have negative 2x is equal to 20. I divide both sides by negative 2, and I get a single number. I get that x is equal to negative 10. So using a number line, I can display that visually by saying, this is my solution for this equation, negative 2x minus 5 equals 15. And again, that means that if I replace x with negative 10, I would get the same value on the left as I have on the right. So that, at this point, we should all know. And let me go ahead and write that in solution set notation, where I have negative 10 inside of some set braces. So now let's kind of get into the main topic here. So a linear equation in two variables is of the form, and we see ax plus by equals c. So the first thing I want to call your attention to is our variable x and our variable y, each is raised to the first power. Remember, if you have a variable or a number, and there's no exponent that's visible, it's understood to have an exponent of 1. So I could do this. Now, if you see something like ax squared plus by squared equals c, that's not a linear equation. Okay? So the fact that the exponent is 1 in each case, or you don't see an exponent, is what makes it a linear equation. All right, so the next thing that I want to call your attention to, we have this a. Let me kind of highlight this in a different color. We have a, we have b, and we have c. So for each of these, we kind of say in our book, and if you're fumbling through a textbook right now, you would see something like a, b, and c are real numbers with one restriction. It's not allowed for a and b to be 0 at the same time. So in other words, a could be 0 if b is not. B could be 0 if a is not, but a and b cannot both be 0 again at the same time. So I'll just write here that a and b are not both 0. Okay? And the reason for that is if they were both 0, think about if I plugged in a 0 here and here, well, 0 times x would be 0, 0 times y would be 0, you'd have 0 equals c. Well, that's only true if c is 0. So your variables would basically drop out, right? So what would be the point there? So a and b are not both 0. A, b, and c are real numbers. So let's look at two quick examples. So we have 2x plus 5y equals 7. We have negative 3x minus 7y equals negative 18. So again, in each case, you can kind of match this up with what I showed you as your generic example. So a here is 2, b here is 5, c here is 7. You have x to the first power, you have y to the first power. If I look at this example below, a is negative 3, b is negative 7, and c is negative 18. So very easy to kind of line these up with a generic example and see what we mean when we talk about a linear equation in two variables. All right, so the main thing that's different is that when we work with a linear equation in two variables, it's no longer going to be one solution. There's an infinite number of solutions that's going to work. So for this reason, we generally are going to graph our solution set to the equation to give a visual representation of what's going on. Now, we're not going to graph in this lesson, but we're going to do the things that lead up to us being able to graph. And you know from Algebra 1, if you took an Algebra 1 course, that graphing is not very difficult, right? It's actually very, very easy. So the first thing we need to understand is something called an ordered pair. So a solution to a linear equation in two variables is called an ordered pair. So generically, we work with x and y, okay? So x is in the first position. So it's always first. And then y is always second. So if I give you an ordered pair like 3, 2, and I say it's a solution to a certain linear equation in two variables, that means that I can plug in a 3 for x and a 2 for y, and I would get a true statement. Right? The left and the right side would be equal. So the main question you might be asking right now is, how do we get an ordered pair, or how do we get such a solution for an equation? Well, basically we pick a number and plug in for one of the variables, and then we solve for the other. So I can pick whatever number I want for x, and then I can solve for y. Or I could pick whatever number I want for y, and then solve for x. And there's, again, an infinite number of solutions. I can choose any number I want, and I'll be able to get a solution for the other one. So let's just start out with x equals to 0. That's an easy one. So let's say x equals 0. So I would say 2 times 0 minus 5y equals 20. And what I'm basically doing is, by plugging something in, I'm creating a linear equation in one variable that I can solve quite easily. So 2 times 0 is 0, so we'll put 0 there. Negative 5y equals 20, so we divide both sides by negative 5. That will cancel. I'll have y is equal to negative 4. So it's important to note what we did here. I plugged in a 0 for x, so that means this ordered pair here, remember it's x comma y, so it would be a 0 for x, and it would be a negative 4 for y. And just plug in. Let me just erase everything and start from scratch. Let's pretend you're given this ordered pair, and you say, hey, does this work as a solution? Well, I'm plugging in a 0 for x. Okay, this is my x value. And I'm plugging in a negative 4 for y. That's all I'm doing. So 2 times 0 minus 5 times negative 4, does that equal 20? 2 times 0 again is 0. Negative 5 times negative 4 is positive 20. So yeah, of course this does work. 20 is going to equal 20. So yeah, that works as a solution. All right, let's just try something else. Let's say I picked some number for y. Doesn't matter what it is. Let's just say 6. Okay, that's nice and easy. So I plug in a 6 for y. Well, I'll have 2x minus 5 times 6 equals 20. So I'm going to evaluate this. Negative 5 times 6 is negative 30. So I'd have 2x minus 30 is equal to 20. I would add 30 to both sides of the equation. This would cancel. I'll have 2x is equal to 20 plus 30 is 50. Divide both sides by 2. And finally, I'd find that x is equal to 25. So when y is 6, okay, I plugged in a 6 there to start, x is 25. So again, following this format, the x value is first, so that's 25. The y value is second, so that's 6. And again, I can generate as many of these as I'd like. Pick something for x, solve for y. Pick something for y, solve for x. All right, so let's kind of look at our first kind of sample problem here. This is something you're definitely going to see in your textbook. As you get into starting to graph these linear equations in two variables, the first thing you do, or the first thing you're taught, is how to create a table of values. What this is going to do is it's going to give you some ordered pairs that you're then going to plot on the coordinate plane, and then you'll sketch a line through those ordered pairs to create your graph. Well, we're not there yet. We're still working on this, but I just want you to know where we're going. So we have 4x minus 3y equals negative 12. Now I'm given a table with some values filled in for me. So for example, I'm given an x value of 0 here. So what they're saying for me to do here is to take this equation. So 4x minus 3y equals negative 12. Plug in a 0 for x and see what I get for y. So 4 times 0 would obviously be 0. Minus 3y equals negative 12. So this is gone. Basically, all I need to do to solve this is divide both sides by negative 3. That would cancel, and I'd have y is equal to 4. So I can fill in my missing part here and put a 4 there. So the ordered pair there would be 0, 4. Again, it's the x value first, followed by the y value second. And just write that down in your notes. Just put x, y, so you can refer to it as we're doing this. And this is something you're going to remember for the rest of your life. X, y is the ordered pair. All right, for the next one, we're given a y value of 0. So for the y value of 0, I go 4x minus 3 times 0. Just plug in a 0 there, which corresponds to right here, equals negative 12. 3 times 0 is obviously 0, so that's gone. So we'll have 4x is equal to negative 12. Let's divide both sides by 4. That'll cancel, and we'll have x is equal to -3. So when y is 0, x equals -3. Again, as an ordered pair, x comes first, so that's -3, comma, y goes second, so that's 0. So this is your x, this is your y. All right, let's take a look at one more. So now we're given an x value of 3, okay, of 3. So let's plug that in. So we have 4 times, for x, again, I'm plugging in a 3. That's all I'm doing. Then minus 3y equals -12. 4 times 3 is 12. Minus 3y equals -12. Let me subtract 12 away from each side. So that cancels. Scroll down to get a little room. So then I'd have -3y on the left is equal to -12 minus 12 is -24. Divide both sides by -3. So this would cancel, and I'll have y is equal to 8. So when x is 3, y is 8. Let me erase this so we can get everything back on the screen. Okay, let me scroll up here. So as an ordered pair, this would be 3 for x, comma 8 for y. So this is x, and this is y. So a pretty simple exercise overall. For sure, you'll probably get this on your homework or on a test, where they give you a linear equation in 2 variables, and they'll either tell you to make a table with a certain number of ordered pairs, or they'll give you an ordered pair where the x value or the y value is missing, like we did here. All right, let's take a look at one more of these. So we have -x plus 7y equals 28. So I'm given my table of values. I have x values, I have y values. So the first one gives me an x value of 7. So I'm going to plug that in there. Plug in a 7 there. Don't forget that negative. So put the negative and then plug in a 7. Plus 7y equals 28. Let's add 7 to each side. So that cancels. We'll have 7y is equal to 35. We'll divide both sides by 7. We get y is equal to 5. So when x is 7, y is 5. Okay, so let me erase this. And that's the ordered pair. Remember, the x value is first, so that's 7, comma, the y value is second, so that's 5. So this is x, and this is y. All right, for the next one, we are given a y value of 3. So we're going to plug in a 3 here, and we're going to solve for x. So we have -x plus 7 times 3 is equal to 28. Let me say that 7 times 3 is 21. So -x plus 21 equals 28. Let me subtract 21 away from each side of the equation. So this is going to cancel. We'll have -x is equal to 28 minus 21 is 7. We'll divide both sides by -1 or multiply by -1, whatever you want to do. So that'll cancel itself out, and I'll have x is equal to -7. So when y is +3, x is -7. So as an ordered pair, you could write this as -7 for the x value, comma 3 for the y value. All right, for the next one, we're given an x value of 0. So I'm going to plug that in right there. Okay, I want a 0 there. So negative, and then you have 0, plus 7y equals 28. The opposite of 0 is just 0, right? So this, you just cancel that out and say, I'm just dealing with 7y equals 28. We would divide both sides by 7, and we would find that y is equal to 4. So when x is 0, y is 4. So we have 0, comma 4. Again, 0 is the x value, 4 is the y value. So pretty simple exercise overall. Not going to do any more of these for now, but you can pretty much tell what you need to do. If you're given an x, you plug in for x in that equation and you solve for y. If you're given a y, you plug in for y in that equation and you solve for x. And then just report your answer as an ordered pair. Remember, the x value goes first, comma, your y value. So kind of the next thing we need to learn before we start graphing these linear equations in 2 variables is what to actually do with the ordered pairs. What's going to happen is we're going to end up plotting them on something known as the coordinate plane. So this is the coordinate plane. And for those of you, again, that took Algebra 1, you're very familiar with this. We did a lot of work with this in Algebra 1. But if you've never taken that course, this is new to you. So let me give you a couple of tidbits of information here. The first thing is that this thing has many names. The official name for it is the Cartesian Coordinate System. And it's named after a guy that was sick in his bed and he watched the fly kind of, go back and forth. So he came up with the idea for this. The other name you might hear is the Rectangular Coordinate System. But most often, I think that you'll hear it called the coordinate plane. But it's interesting to know those three names because those are used most often. And if your book uses something different, I don't want you to be confused. Well, what was he talking about? He said coordinate plane. They're calling it this Cartesian thing. So it's important to kind of know other names for it so you don't get confused. The other thing would be, how does it work? Well, it's two number lines basically that intersect where they're each at 0. So this is the intersection of the two. It's the point 0, 0. So the x value is 0, the y value is 0. And it's, again, the intersection of the two. This is referred to as the origin. And you're going to hear that a lot throughout your study of mathematics. Whenever you talk about the coordinate plane, somebody refers to the origin. They're talking about this point right here, 0, 0. Now, another thing that's important is the horizontal number line is referring to x locations. So we refer to this as the x-axis. Now, similarly, the vertical axis refers to y locations. So this is referred to as the y-axis. And to plot an ordered pair is very, very simple. If I give you something like 4, 3 as an example, this is your x value, this is your y value. So that just translates to finding the x location of 4, finding the y location of 3, and just getting the meeting point. So an x location of 4, I look at the x-axis. Again, the horizontal axis. So I go from the origin, 1, 2, 3, 4 units to the right, or I could just start at 4, either way. So that's an x location of 4. A y location of 3, I just go up 3 units to right here. And where's the meeting point? Well, I would go 1, 2, 3, 4 units to the right, and I would travel 1, 2, 3 units up. So it's right there. And it works either way. If I want to go 1, 2, 3 units up, and then 1, 2, 3, 4 units to the right, I get to the same location. So this is the point, which I'll label 4, 3. And 4, 3 is known as the coordinates of the point. It tells us where to go, right? We go 4 units to the right and 3 units up to get to this point. Now, just one more piece of information before we look at some examples of plotting ordered pairs. You'll probably be taught in your textbook, and this is very brief, about the quadrants. So the quadrants go counterclockwise. So you kind of think about each section here. This is section 1 or quadrant 1. So that encompasses this. This is quadrant 1. And then you'd have quadrant 2. Let me do that in a different color. So this is 2. And this is 3. And this is 4. So again, counterclockwise. So you can highlight this in a different color. This is 2. And I'm trying not to go over the line. I know I'm terrible at drawing, but I'm trying. And then let's do this one in a different color. This is 3. And then one last color. Let's do orange for 4. Okay. And I know I went over the line in a couple places, but you should get the idea. So quadrant 1 just encompasses all of this, right? And it extends forever and ever and ever in this direction, right? It goes forever. But it's all the values that would be in here. And one of the things we can say about quadrant 1 is what? Well, we know that the x location and the y location are each going to be positive. Because anything in this quadrant here, you can see it highlighted in yellow, is going to be to the right of 0, and it's going to be on top of 0, moving up from 0. So the direction going to the right is positive, the direction going up is positive. So anything in quadrant 1 is positive, positive. So quadrant 1 is positive, positive. So this is your x and this is your y. For quadrant 2, what can you say? Well, the x locations are going to be negative. The y locations are positive because we go to the left of 0 and we go north of 0. So that's going to tell me that in quadrant 2, again, my x location is negative, my y location is positive. In quadrant 3, I am negative and negative because my x location is to the left of 0, my y location is south of 0. So for quadrant 3, I am negative, negative. And then finally for quadrant 4, I am positive in the x values because I'm right of 0, And then I'm negative in y values because I'm south of 0. So this is positive, negative. And you might be tested on something like this. It might say, for example, what are the values in quadrant 2? And you might get flustered and say, well, I didn't memorize that. You don't need to. Just draw yourself a sample coordinate plane. They're very easy to draw. And once you do that, you can just eyeball it and say, well, I know that anything in quadrant 2 would be to the left of 0 and north of 0. So my x values would be negative, my y values would be positive. All right, so let's wrap up this lesson. And we're just going to plot some ordered pairs. So we're going to start out with 0, 7. So again, it's x location followed by y location. So let me just write this real quick. It's x, y. And let me just label this too so that we don't get confused. This is the y-axis. And this, let me kind of scroll over. This is your x-axis. Now, an x location of 0 is not confusing. A lot of you get confused with this. If I look at the x-axis, just kind of block out the y-axis for a second. Just pretend this isn't here. If I have a regular number line we've been working with forever and ever and ever, where is 0? It's right here. Okay? So where is 7 as far as a y location? Now we can erase this and think about 7. It's right here. So if I go 0 units on the x-axis, I just don't move. I start at the origin, I don't move. And if I go 7 units up on the y-axis, I'm right here. So this is going to be 0, 7. Now for the next one, I have the ordered pair 3, 5. So I would go 3 units to the right, or an x location of 3, and 5 units up. Up 1, 2, 3, 4, 5. So that's a y location of 5. So this is 3, 5. What about negative 2, negative 7? So I go 2 units to the left. Here's negative 2. I go 7 units down. Here's negative 7. So 2 units to the left, 7 units down is right here. So this is negative 2, negative 7. Next we have 8, 1. So I would find 8 on the x-axis. And let's do this one backwards. Again, you can do the y location first if you want. So let's find 1 on the y-axis, that's here. Now let's find 8 on the x-axis, that's here. So let me go up 1 and to the right 8. So that's here. So this is 8, 1. All right, lastly we have 9, negative 6. So I'm going to find 9 on the x-axis, that's here. Negative 6 on the y-axis, that's here. So I'm going 9 units to the right and 6 units down. So that's going to be right here. Okay, so this is 9, negative 6. So very, very easy. In terms of things that you will come across in algebra, this is probably one of the easiest things to do, to plot an ordered pair. You literally just go to the coordinate plane and have to memorize 2 things. The x-axis and the y-axis. The x-axis is horizontal, the y-axis is vertical. You do that just a few times and you've got that down. So basically it's just a matter of finding the meeting point of the x location and the y location, putting a little dot there, and in most cases when you're plotting ordered pairs, you just ask you to label it like we did here.